In this video, we will do problems from exercise 8.3. So question number 1 says find A vector dot product with B vector when you're given vector A and B by this, and you have two questions here. So let's do the first one. Before we go to solve the questions, for any vector A equals A1 I cap plus A2 j cap plus A3 k cap, and vector B which is B1 I cap plus B2 j cap plus B3 k cap, A vector dot product with B vector is equal to A1 B1 plus A2 B2 plus A3 B3. So now let's apply this onto our first question. So in the first question, vector A is given by I cap minus 2 j cap plus k cap, and our vector B is given by 3 I cap minus 4 j cap minus 2 k cap. So A dot product with B will be equal to 1 into 3 plus minus 2 into minus 4 plus 1 into minus 2. So that's equal to 3 plus 8 minus 2, which is equal to 9. Similarly, let's do the second one. So in the second one, vector A is equal to 2 I cap plus 2 j cap minus k cap, and vector B is equal to 6 I cap minus 3 j cap plus 2 k cap. So A dot product with B will be equal to 2 times 6 plus 2 times of minus 3 plus minus 1 into 2, which is equal to 12 minus 6 minus 2, which is equal to 4. Question number 2. Find the value of lambda for which the vectors A and B are perpendicular. Where you have two questions here. So let's do the first one. Before we do the first one, let's say when vector A and vector B are perpendicular, then A vector dot product with B vector is equal to 0. So let's take the first question. We are given here vector A is equal to 2 I cap plus lambda j cap plus k cap, and vector B as I cap minus 2 j cap plus 3 k cap. So here our A vector dot product with B vector is equal to 0, which implies, let's find A dot product with B, which is 2 times 1 will be 2 minus 2 times lambda plus 3 is equal to 0, which implies our 2 lambda is equal to 5. That means our lambda is equal to 5 by 2. Now let's solve the second problem. The second problem, vector A is given as 2 I cap plus 4 j cap minus k cap, and vector B is given as 3 I cap minus 2 j cap plus lambda k cap. Again, our vector A dot product B is equal to 0, which implies 2 times 3 is 6 plus 4 into minus 2 minus 1 minus lambda is equal to 0, which implies that our lambda is equal to 6 minus 8, which is equal to minus 2. So our lambda is equal to minus 2. Question number 3. If vector A and vector B are two vectors such that magnitude of vector A is 10, magnitude of vector B is 15, and vector A dot product with vector B is equal to 75 square root of 2. Find the angle between vector A and vector B. So here, given to us, vector A magnitude is equal to 10, vector B magnitude is equal to 15, and vector A dot product with vector B is equal to 75 square root of 2. Now, the angle between vector A and vector B is given by the formula cos theta is equal to vector A dot product vector B divided by magnitude of A into the magnitude of B. So substituting the values here, 75 root 2, which is A dot product with B, which is here, divided by magnitude of A is 10 times magnitude of B is 15. So further solving this, you will get 75 square root of 2 divided by 150. So 150 can go in 2 times, so it is square root of 2 by 2. Further, we can write this as square root of 2 divided by root 2 into root 2, which is nothing but 1 by root 2. So we have our cos theta is equal to 1 by root 2, which implies our theta is equal to cos inverse of 1 by root 2, which is equal to pi by 4. Hence the result. Question number 4. Find the angle between the vectors. There are 2 vectors given in question number 1 and 2 given here in 2. So let's do the first one. Before we do that, let's define, let theta be the angle between vector A and vector B. Then cos theta is equal to vector A dot product vector B divided by magnitude of A into magnitude of B. So let's define for the first one our vector A as equal to 2i cap plus 3j cap minus 6k cap, and vector B as 6i cap minus 3j cap plus 2k cap. Therefore, our vector A dot product with vector B is equal to 2 times 6 plus 3 times minus 3 plus minus 6 times 2. So simplifying this, 12 minus 9 minus 12, which is equal to minus 9. And our magnitude of A is equal to square root of 2 squared plus 3 squared plus minus 6 the whole squared. So 2 squared plus 3 squared plus minus 6 the whole squared, which is equal to 4 plus 9 plus 36, which is equal to root of 49, and that's equal to 7. Similarly, magnitude of B is defined as the root of 6 squared plus minus 3 the whole squared plus 2 squared, which is equal to 36 plus 9 plus 4, which is equal to root of 49, which is equal to 7. Therefore, our cos theta is equal to vector A dot product with B divided by magnitude of A into magnitude of B, which is equal to our A dot product with B is minus 9. Minus 9 divided by 7 times 7, which is equal to minus 9 by 49. Therefore, our theta is equal to cos inverse of minus 9 over 49. Let's do the second one now. So in the second one, vector A is equal to I cap minus j cap, and vector B is equal to j cap minus k cap. So our A dot product with B is equal to 1 times 0 plus minus 1 times 1 plus 0 into minus 1, which is equal to minus 1. And our magnitude of A is equal to square root of 1 squared plus minus 1 squared, which will be equal to root of 2. And our magnitude of B is equal to square root of 1 squared plus minus 1 squared, which is also equal to root of 2. Therefore, our cos theta is equal to A dot product with B divided by magnitude of A into magnitude of B, which is equal to minus 1 divided by root 2 into root 2, which is equal to minus 1 by 2. Therefore, our theta is equal to cos inverse of minus 1 by 2. Therefore, our theta is equal to pi minus pi by 3. So that will be equal to 2 pi by 3. Question number 5. If A, B, C are three vectors such that vector A plus 2B vector plus C vector is equal to 0 vector, and we're given magnitude of A is 3 and magnitude of B is 4, magnitude of C is 7. Find the angle between vector A and vector B. So we know that to find the angle, if we are able to find theta, which is the angle between vector A and B, and cos theta is equal to A dot product with B divided by magnitude of A into magnitude of B. So what is given to us is, given vector A plus 2B vector plus C vector is equal to 0, and we are also given magnitude of A is equal to 3 and the magnitude of B is 4 and the magnitude of C is 7. So if we rewrite this, what is given here as vector A plus 2B vector is equal to minus C vector, and further if we square both the sides, you would get vector A plus 2B vector squared is equal to minus C vector squared. So further we can expand this as A squared plus 4 times vector B squared plus 4 times vector A dot product with vector B is equal to C vector squared. Now we can rewrite this as magnitude of A squared plus 4 times magnitude of B squared plus 4 times vector A dot product with B is equal to magnitude of C squared. So further we can expand this or replace the values of the magnitudes. So this is 3 squared plus 4 times 4 squared plus 4A dot product with B is equal to 7 squared. So further simplifying this, we can say that 4 times A dot product with B is equal to 49 minus 9 minus 64, which is equal to minus 24. So therefore, which implies A dot product with B is equal to minus 24 by 4. That's equal to minus 6. So our cos theta is equal to minus 6 divided by 3 times 4, which is equal to minus 6 by 12, which is minus 1 by 2. Therefore, our theta is equal to cos inverse of minus 1 by 2, which is our theta is equal to pi minus pi by 3, which is equal to 2 pi by 3. Question number 6. Show that the vectors A, B and C are mutually orthogonal. When you say mutually orthogonal, which means, let's say this is vector A, this is vector B, and this is vector C. So when they're mutually orthogonal, this angle is 90 degrees, this angle is 90 degrees, and this angle is also 90 degrees. So we have to prove that A dot product with B is equal to 0, B dot product with C is equal to 0, and C dot product with A is equal to 0. Then they are all mutually orthogonal. So what are we given? We're given vector A is equal to 2i cap plus 3j cap plus 6k cap, and vector B is equal to 6i cap plus 2j cap minus 3k cap, and vector C is equal to 3i cap minus 6j cap plus 2k cap. So first let's find A dot product with B. So that's equal to 2 times 6 plus 3 times 2 plus 6 times minus 3, which is equal to 12 plus 6 minus 18, and that's equal to 0. Next, let's find B dot product with C, and that will be equal to 6 times 3 plus 2 times minus 6 plus minus 3 times 2. That's equal to 18 minus 12 minus 6, which is again equal to 0. And let's find the last, which is vector A dot product with vector C. That would be 2 times 3 plus 3 times minus 6 plus 6 times 2, and that's equal to 6 minus 18 plus 12, which is also equal to 0. Therefore, we can say that A is perpendicular to B, B is perpendicular to vector A, vector B, B, C, and vector A is perpendicular to vector C. Therefore, vector A, B, C are mutually orthogonal. Question number 7. Show that the vectors minus I cap minus 2j cap minus 6k cap and 2i cap minus j cap plus k cap and minus I cap plus 3j cap plus 5k cap form a right angle triangle. So for them to form a right angle triangle, so you have to prove that these three vectors, let's call them as vector A, B and C. We do not know which is on which side, just for assumption. So first we need to prove that it's a triangle, they form a triangle, and then we have to prove that two sides form or two sides are perpendicular. Then we can show that this is a right angle triangle. So to prove it's a triangle, if you add all the sides A, B and C, you should get 0, which means if you add the three vectors, you should get 0. And for perpendicular, you have to show that any two sides, let's say assume that maybe B dot product with C is equal to 0, then these two sides are perpendicular. So now let's try and do the problem. Let vector A is equal to minus I cap minus 2j cap minus 6k cap. Vector B is equal to 2I cap minus j cap plus k cap, and vector C is equal to minus I cap plus 3j cap plus 5k cap. For A, B, C to form a triangle, to prove vector A plus vector B plus vector C is equal to 0. So vector A plus vector B plus vector C is equal to minus I cap minus 2j cap minus 6k cap plus 2I cap minus j cap plus k cap minus I cap plus 3j cap plus 5k cap. So if you add them together, minus 1 plus 2 minus 1 will be 0, and you will have minus 2 minus 1, so minus 3 plus 3 will be again 0, and you will also have minus 6 plus 1, which is minus 5, plus 5 will be again 0. So this is equal to 0. Therefore, A, B, C are sides of a triangle. Next, let's prove that any of the two sides dot product is equal to 0. So let's try A dot product with B. So A dot product with B will be minus 1 into 2 plus minus 2 into minus 1 plus minus 6 into 1, which would be equal to minus 2 plus 2 minus 6, which is equal to minus 6. Therefore, A and B are not perpendicular. Now let's try B with C vector. So B with C will be 2 times minus 1 plus minus 1 times 3 plus 1 times 5, which is equal to minus 2 minus 3 plus 5, which is equal to 0. Therefore, B vector is perpendicular to vector C. Therefore, A, B, C are sides of a right angled triangle. Question number 8. If vector A's magnitude is equal to 5 and magnitude of B vector is 6, magnitude of C vector is 7, and A vector plus B vector plus C vector is equal to 0 vector, find A dot product with B plus B dot product with C plus C dot product with A vector. So we are given vector A magnitude as 5, vector B magnitude as 6, vector C magnitude as 7, and A vector plus B vector plus C vector is equal to 0 vector. So let's take this and let's square it. So A vector plus B vector plus C vector squared is equal to 0. Therefore, expanding this, we can write, we know that A squared vector is the same as magnitude of A squared. So magnitude of A squared plus magnitude of B squared plus magnitude of C squared plus 2 times of A dot product with B plus B dot product with C plus C dot product with A, and this is equal to 0. So we know the values of these, so let's substitute the values. So it's 5 squared plus 6 squared plus 7 squared plus 2 times A dot product with B plus B dot product with C plus C dot product with A is equal to 0. So further simplifying this, we can say that 2 times A dot product with B plus B dot product with C plus C dot product with A is equal to minus 25 minus 36 minus 49, which is equal to minus 110. Therefore, A dot product with B plus B dot product with C plus C dot product with A is equal to minus 110 divided by 2, which is equal to minus 55. That's the required answer. Question number 9. Show that the points 2, minus 1, 3, 4, 3, 1 and 3, 1 and 2 are collinear. So you're given 3 points. We have to show that these 3 points are collinear. Okay, so let's call these as A, B and C points, and we are given the, if we take the position vectors and then we are given the points, so we can find OA vector, OB vector and OC vector, then from there find AB vector and then find BC vector, and if we find that AB vector is a multiple of BC vector, then they are coplanar. So let's solve the problem. Let A, B, C be the given points such that OA vector is equal to 2 I cap minus j cap plus 3 k cap. OB vector is equal to 4 I cap plus 3 j cap plus k cap. OC vector is equal to 3 I cap plus j cap plus 2 k cap. Next, let's find vector AB. Vector AB is equal to OB vector minus OA vector, which is equal to 4 I cap plus 3 j cap plus k cap minus 2 I cap minus j cap plus 3 k cap. So that's equal to 2 I cap plus 4 j cap minus 2 k cap. Similarly, let's find vector AC. That's equal to OC vector minus OA vector, which is equal to 3 I cap plus j cap plus 2 k cap minus 2 I cap minus j cap plus 3 k cap. Solving this, we can say I cap plus 2 j cap minus k cap. So you can see that vector AB is 2 times the vector AC. So vector AB is equal to 2 times vector AC. Therefore, vector AB and vector AC are collinear vectors, and therefore the points A, B, C or collinear. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.